Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, and in this part we'll be showing the use of HSM's Constant Z machining and our helical machining. In the part that you see here, I like to use a finish cut to go down these walls over here, and I'll be first using the option of Constant Z. If I go into my operation and open up my HSM, I'll start off by using the option Constant Z. And the tool that I will be using will be a 10mm tool with a 1mm radius at the edge. Now, my constraint boundaries, I'll be using Create Automatically, and I'll be using the option of Auto Create Outer Silhouette, which means I'll be actually taking the outside shape of the tool, of the part itself, as shown over here. Now, in my passes, since this is my finish pass, I'll be using a thickness of 0 because it's my finish. And my step down will be every 2mm. Okay, I won't do anything else at this point, except for at the bottom, I want to go only up until this floor over there. Now, in my link area, I'm going to change my maximum stock thickness to 1. This is done so that in the part as you see over here, it'll first work on this area and then jump over to this particular area over here. I'll simply do now save and calculate, and I'll use my simulation, and I'll use the HostCAD simulation so that we can see the actual tool pass on the part itself. And as you see, my tool will go down exactly every 2mm, finish down to the very bottom, and then it'll jump over to this area over here and also finish this particular stub as shown over here. If we take a look at our side view, you'll note that it goes down, and every single time it goes down and it works to its next pass, it actually goes down at an angle, keeping a smooth pass around the part and only having one entrance and one exit at the bottom of this part, and then only then going over to our next stub area. Now, if we take a look at our tool pass, you'll note that these areas actually have a wider step over than the ones that it really should have. For that, we have the option of using scallop, which will actually give us the proper tool path that we need on the part. I'll go back into my part itself, and I'll make a certain change. If I go into my passes area, we have the option here called adaptive step down. Now, what the adaptive step down actually does, actually gives me the option of using my scallop. Now, if you note, I have my minimum step down of 0.2mm, but my profile step in at this moment is 8mm. If I use the option now of step down by scallop, it'll automatically change my profile step in the exact same way my minimum step down is. And this will give me actually a scallop finish. Now, if I use save and calculate, now, if we take a look at our simulation this time, you'll note that this time, and I'll use this time a side view, you'll see that in these areas over here, it's doing actually its scallop step around the part. But when we have a straight wall, it'll actually move down every 2mm. Again, when it gets to this area where we have an angle, it'll actually use the scallop option and work its way all the way down, giving us a smooth, even cut all around the part as we go down. What I'd like to do now is actually show you a different operation that we can use to finish these walls over here, and this option is called helical machining. What helical machining actually does, it'll go around the part itself, but every single time it goes around, it'll go down a certain amount according to the amount that I will specify shortly, and it'll work its way all the way down until it gets to the bottom over here, leaving for an even cut all around the part, which will actually give an excellent finish. Let's see how this works. Again, I'll be using the helical machining as I said. The tool, I'll use the exact same tool I used last time, and the same thing with the boundaries. Now, in my passes area, again, I only want to go down to that floor over there, and I'll be going down of a step down of every 1mm. It should also be noted that my maximum ramp angle, as seen in the picture over here, will be 5 degrees. In other words, there won't be more than 5 degrees of an angle as we're going down on the part. Now let's do quick save and calculate. And if we take a look at our simulation, and we'll take a look at it at our side view, you'll see that the toolpath is actually going one entrance and is actually working around in a helical fashion all the time. There are no lead ins or lead out into any of the toolpath. It's exactly one smooth toothpath around the part itself, leaving for an excellent finish around the entire part. Thank you for joining us on Solid Professor. Take care and have a nice day.